speak. I'll look forward to Nolan's talk. I assume that's probably on like rare earth elements out of coals and extraction.
Extraction side of that.
Yeah, well, I apologize for those that are missing that because this will be interesting in its own way, but I'm definitely going to attend that virtually. So thanks for everybody that came, both in person and online. And if you have any questions or comments, both now or in the future, feel free to reach out to me. So as introduced, Timothy Nesheim. I've been working mostly on subsurface petroleum geology in North Dakota for the last 15 and a half years. And what I'm talking about is non-Bakken plays that have had some recent activity. Things, and this actually isn't touching on everything too. There's a lot of other projects, wells, even though the Bakken Three Forks takes the lion's share of activity and production to date, there's a lot of other things that have happened in the background. And this is just touching on a few things I thought to be interesting. This talk is actually one I initially gave at the North Dakota Petroleum Council annual meeting last September. And then I gave a slightly expanded version of it at the Rocky Mountain Section annual meeting in Keystone, Colorado, back in October 5 to 7. And that's where this slideshow is from. And so this will be the third time of giving this presentation. And it was about 25 minutes when I had it rehearsed. I'll probably give it a little bit looser. That'll probably be more like 30 minutes would be my guess. I'll try to not get too rambly. So most of you are familiar with the Williston Basin to one degree or another, but as kind of a refresher overview, on the left slide here, you have an extent map of the Williston Basin, which I think that extent outline, I've been told by a few older geologists that it's kind of a BS outline, but I like it because it kind of looks like a polar bear with its head nose off to the northwest. There's a foot, another foot down there. And in the middle of it, you've got the core of the basin, the heart of the polar bear, where you have most of the oil generation and production in the Bakken. And this map is also showing the distribution of Bakken Three Forks oil wells in black, Madison wells in orange, Red River wells in blue. Those are like the three main oil producing horizons within the Williston Basin. However, for the whole Williston Basin, there's something on the order of about 24 geologic formations across the whole basin that have commercially produced some oil and gas. Deep thermogenic gas in the Cambrian Ordovician Deadwood Formation, Black Island, and shallow biogenic gas up in the Cretaceous section, and then mostly oil production in between. And so 24 different formations, some have produced more than others. Like I said, the big three is like the Bakken Three Forks, the Madison group. The Bakken has produced, and Three Forks have produced over 6 billion barrels across the whole basin. The Madison group reservoirs are somewhere north of 4 billion barrels. Those are your billion barrel club members. And then the Red River Formation is number 3, where across the whole basin, you're probably around 550 million barrels of oil, plus gas production. I predict at some point in my lifetime the Red River will be part of the Billion Barrel Club membership. So today I'm talking about, I think it's 4 or 5 different test wells and some plays that went into some development within the last 10 to 15 years. On the introduction to each of these plays, I'm going to have an index map on the top left that shows an outline of North Dakota with counties, stars that show our sort of majorish metropolitan areas from Fargo and Grand Forks to the east, Bismarck, Minot in the middle, Dickinson, Williston, and then that bigger star is Watford City, which is near the deepest central portions of the basin. And then I'll have kind of an outline of the play area I'm talking about. I'll also have a stratigraphic column on the left that shows kind of where the Bakken Formation is lying for reference, and then the unit of interest we're talking about. So that'll give you kind of a spatial area of where we're talking about. And then on the stratigraphic column, you're getting a reference point of is it below or above the Bakken. Because I've realized over the last 15 and a half years that a lot of people, they like to know those things. How deep are we? Where are we at? And so the first one I'm talking about is the Winnipeg group. It is not anywhere near being part of the Billion Barrel Club membership in the basin, but maybe one day. In the Winnipeg group, it's one of our deepest oil producing units. It overlies the Deadwood Formation. And this unit is made up of 3 different formations. The Black Island is the lowest unit, which is really sandy, sandstone dominated. The Ice Box Formation is more of a siliciclastic mudstone or shale. And as you get into the Rough Rock Formation that makes up the upper unit, The rough rock's a transitional unit going from a shale going into a carbonate in the Lower Red River Formation. There's not a lot of literature work on the rough rock. It hasn't produced any hydrocarbons, but it's kind of a transitional zone and going from siliciclastic sedimentation to carbonate. And on the right is a map showing the distribution of oil and gas wells that are produced out of this petroleum system. These red wells that are in western North Dakota along the Nesheim Antelope anticlines, those are these primarily dry gas producing wells with little to no condensate. It's mostly methane production. And some of those wells have produced over 20 BCF of gas. I'll be talking about that later. Near Dickinson, there's a few wells that are yellow colored where you have gas condensate production, where condensate's like a really light oil being produced along with a lot of gas. And then up in Saskatchewan, you have these green circles that are oil producing. And so, it's only produced from a few dozen wells, but over a large distributed area. And then faded in there, you have oil and gas shows that show a very large, much larger petroleum system. Only probably on the order of hundreds of wells have penetrated this formation because it's one of the deepest units in the basin. The icebox formation, focusing on that because there was a test well I'll talk about in a moment. It's this big, thick, kind of shale siliciclastic mudstone. Some of it is organic rich. A plot here in the middle is showing kind of the kerogen signature type. And if you look at the less mature organic rich parts of the icebox, it's like a type 1 oil prone generating mudstone or organic rich kerogen type. If you look at the depth and thermal maturity of the icebox formation, this map on the left was made by Steve Nording. It's a time temperature index map where basically the red area is where almost all of the original organic carbon that could turn into oil and gas that was deposited has turned into oil and gas. And it's in that over mature window where it's just thoroughly cooked. The green interval is where you're somewhere in the oil generation window, where organic carbon or kerogen is converting into oil and gas to varying degrees. And so this is a deeper and hotter unit than the Bakken Formation, which is why it tends to be a lot more gas dominated. And with the icebox, one thing in most petroleum source rocks are these higher gamma ray organic rich muds where you bury them, they get hot for long enough, and some of the organic material turns into oil and gas. And most petroleum source rocks, the total organic carbon content or the organic richness, it trends with the gamma ray signature, kind of the radioactivity of the rock. With the icebox, this is one of those exceptions where the higher organic richness or the higher TOC shales have more of an intermediate gamma ray signature, and the higher gamma rays doesn't necessarily mean higher organic carbon concentrations. So this is an odd shale that hasn't really been well studied. Some of it is real organic rich and prone to generating oil, some is not. And I'll leave it at that. And underlying the icebox formation, you have the reservoir of the petroleum system, the Black Island Formation. With the Black Island, this is something I worked on about 10 years ago or 12, 13 years ago. And when I first worked on the Black Island, I logged some cores, I did some subsurface correlations, and then I looked at production from the Black Island. And along the Nesheim anticline, you have these wells that produced up to 20 billion cubic feet of gas, which is a lot for onshore, especially Williston Basin. And I noted most of the production came from these clean sands in the Black Island, which I had the term like A sand, B sand, C sand in the Garland member, the upper Black Island, and then there's a Hawkeye Valley sand in the Hawkeye Valley member, the lower Black Island. And I noticed the main pay zone along the Nesheim and Antelope anticlines is this sand A, that's somewhere around 40 feet thick. And I noticed with that sand, it has low gamma ray, meaning low clay content, high resistivity, indicating low water saturations. It has about 5 to 10% log porosity, and a neutron porosity crossover, indicating the presence of gas. So it looks like this sand along the Nesheim anticline is filled with gas, and that's where they produce hydrocarbon gas out of it. When I started looking at the sand off the Nesheim anticline, I noticed it had the same signature: resistivity, moderate porosity, neutron porosity crossover. So I applied the Archie equation, which oil and gas industry has been using probably for like 70 plus years to calculate water saturations. And I noticed this red area is where this sand A has really low water saturations. So it looks like this huge gas-charged area in the Black Island that extends from northern Dunn through almost all of McKinsey up through Montreal, Williams, Divide County. And I haven't calculated like original gas in place. And the one thing I touch on here is the logs can't tell you what type of gas. The production along the Ness and Antelope anticlines is mostly methane, but there were some wells that had up to 20 to 30% nitrogen. And so if you get off structure, is it possible that that's mostly methane? Is it mostly nitrogen? I don't know. And also, one thing that I think helped this reservoir is the permeability of this sand is really low. And what worked along the Ness and Antelope anticlines is natural fracture systems. And in fact, if you listen to some of the old hearings from Amarada Hess engineers and geologists that were recorded from, I think, the late 80s, early 90s, they talked about a dual porosity in the system in the Black Island, where you had the matrix porosity between the mineral grains and a natural fracture system that enhanced the deliverability of hydrocarbons. So you're talking about a low, tight sand reservoir that needed natural fractures to produce out of vertical wells. Sounds a lot like the Bakken, although this is deeper and more gas, less oil. There was a test well in this petroleum system up in Divide County, this green star, which is right along this gas-charged area for the Black Island. With this test well, it's the Shadowcat 131H, drilled by Continental Resources. It drilled down, and this is not a geosteering plot, but it's where I did isopack structure contouring for the Icebox Winnipeg group, and then I dropped in the directional survey. So this is an approximation of where they landed their lateral, not fully confirmed. But it looks like the first few thousand feet of this lateral were in the upper Icebox. The next few thousand feet were in the lower Red River Formation. If you were to go back a couple slides, few slides, when I looked at the organic richness of the Icebox, the highest total organic carbon content and oil generation potential tended to look like it was at the bottom of the Icebox, less as you move up in the upper Icebox. So I suspect this lateral initially landed in organic lean shale, didn't have very good shows, and may have shallowed into the lower Red River to try to see if there was anything up there. So this well mostly produced water, a little bit of gas, so it wasn't a commercial success, but it's the first unconventional test well in this petroleum system. And so it'll be interesting if and when there's another lateral drilled in this. And I can say there's other companies that have cut cores of this formation in the last 10 to 15 years, including EOG Resources, Anschutz, Whiting Oil and Gas, which is now part of Cord. So there have been multiple companies that have drilled wells and cored this unit, and Continental was the first one that drilled a lateral in it. So that's just something to keep an eye on in the future, that it could be a Bakken scale play, maybe, but it's going to be more gas dominated. Next thing I'll talk about is shifting gears to talk about conventional vertical well exploration. We're moving up, we're looking at the Red River Formation, primarily in southwestern North Dakota. In the Red River Formation, you have a series of 4 different dolostone reservoirs referred to the D through the A. Along the Cedar Creek anticline, the Cedar Hills field in Bowman County, they drill horizontals in the Red River B laminated. The unit we're looking at is the D interval. And in the D interval, there was exploration and development in this horizon in the early to mid 2010s that was recently picked back up by another company I'll be talking about. So I have a little study area I looked at in central to northern Golden Valley County, where there was exploration and development about 8 to 12 years ago, and then an exploration fairway that extends to the southeast. And one thing with the Red River Formation, the D interval is where you have the organic-rich oil-generating layers, and you have this conventional porous permeable dolostone interbedded with one another. And if you look at hydrocarbons produced out of the C and D dolomites, which is, here's API oil gravity, gas to oil ratios, which both increase towards basin center. The thermal maturity of the source rocks also increase towards basin center, meaning the produced hydrocarbons and the generated hydrocarbon signatures trend together, indicating lateral hydrocarbon migration is limited. So if the oil is generated in one area, it's not going to move very far before getting trapped and produced. In this area of exploration, there was 2D seismic driven exploration development from 1969 to 2000. 26 wells were drilled, 19 dry holes, 7 producers, 1.2 million barrels of oil. If you run the economics of that, you're going to lose a lot of money. That amount of production per well doesn't pay for all those dry holes. From 2010 to 2017, company Whiting Oil and Gas, followed by a foundation that bought the acreage, drilled a total of 32 vertical wells using 3D seismic. They only had 7 dry holes, 25 producers, and their wells have produced over 2.4 million barrels of oil to date and counting. Where going from 2D to 3D seismic has increased success rates and production at least 2 to 3 times over. What they were looking at was porosity development in that D interval, where, for instance, on this map right here, it's a 3D derived seismic exhibit. In the blue is where this D dolostone porosity is not dolomitized. It's more of a tight limestone. And if you tried to produce hydrocarbons out of it, nothing would flow. Versus in the bright colored areas, that's showing where there is porosity, there is reservoir, and the source rock is interbedded with it, and you get production. Oh. What happened with the slide there? I'll pause for a moment as there's technical difficulties.
This whole system's new.
Okay.
Back.
Okay. Maybe it went to sleep.
I guess so.
Maybe this will. I would just exit out and then
Okay.
redo the slideshow.
Just
escape it.
Hit that, and then
It is back
Hey,
to
there
the
we
screen
okay. Then which button did you use?
now. Well, I clicked from beginning, but you can do from current slide.
Oh wait.
top left.
Oh, from current slide right here.
Yep.
Rejection file.
All right. And then we're back.
You're not sharing right now, I don't think.
Oh.
Box is missing on the outside. Oh, you're right. Yep.
Yeah, just stop sharing.
Oh, stop sharing.
And share again.
Okay, and then
And
sketch
screen.
this one or this one.
Yeah, let's do that one.
All right, looks better. I think we have somebody online kind of checking. So, all right, yeah. So continuing on, basically with 2D seismic, it helps you show like structural closure, like an anticline. With 3D seismic, they're able to tease out how porous the rock is. And in this D interval, Whiting was able to figure out that there's pockets where you have high porosity surrounded by low porosity that helps trap the generated hydrocarbons. There we go. All right. And for scale, this map on the right, see if I get my mouse back. Wait, should I have my mouse? Actually, people on my screen weren't probably seeing the mouse. Maybe I go like this. So that for reference, this map on the right, this is 1 square mile, one section basically. And this little porosity pod is fitting in probably less than a quarter of a section. And the Laird well has been moderately productive. It's over 100,000 barrels of oil and it's still producing about 30 to 40 barrels a day. There we go. Oh. It's not. Well, I was trying to get mouse cursors. There we go. So in this play, there's been some recent exploration where company Wolverine Gas and Oil has drilled a few different wells in this area. 2 are off confidential, and just to the south, southeast. And now you guys see my cursor. These 2 Wolverine wells were drilled using 3D seismic targeting the D interval, and they have perforations in the D, and they're both successful producing wells. These wells initially 150, 160 barrel of oil a day, 30-day averages. After they produced these wells a few months, then they acidized the wells and production jumped up to over 200 barrels a day. If you compare this to a Bakken well's production, it doesn't sound very good, but these are vertical wells that were not hydraulically fractured. So you're not having to drill horizontal, so drilling costs are a little bit less. And then the completion is simply perforating and acidizing. And so the completion costs are a fraction of a multi-stage frac. So they're a lot cheaper to drill than a Bakken well, but they are fairly deep. So in the Red River Formation, if you get something that IPs at initially 200 to 300 barrels of oil a day, or somewhere in that range, you're probably going to make money. And these wells are projected to pay out in about 3 years and produce about 300,000 barrels of oil apiece. And with this play area, the yellow star is where Wolverine drilled those first wells. There's a play area that extends about 2,400 square miles to the southeast. And doing a little bit of volumetric spatial calculations, my estimate is this Red River play fairway, you're talking maybe somewhere around 500 to 1,000 vertical directional wells, and somewhere around the ballpark of 100 million barrels of recoverable prospective reserves of stuff that's undiscovered. So this isn't going to be a billion barrel play like the Bakken, but 100 million barrels, and you're in an area with very little drilling activity to date. And also in that area to the southeast, you have some production out of the upper interlake, maybe some oil shows in the lower interlake. There's a few Bird Bear, Duperow producing wells, and some potential in the Madison as well. So if you're drilling to the Red River, you're going to drill through about 4 or 5 other zones with potential. And so Amadon, North Dakota may actually grow to get like a real police officer at some point. That's my, that'd be my projection. Amadon's maybe going to be more than 10 people or 20 people. Next thing I talk about is a test well drilled by Hess Corporation. And I came across this well actually when I was looking at lower lodgepole scallion test wells, where there's a few wells that companies have drilled just above the Bakken Formation trying to tap into oil that moved up. And those lower lodgepole wells have mostly been pretty mediocre. But as I was looking at it, I came across this well, the Tai Wow well, the Star, up in eastern Williams County along the Nesson Anacline. It was permitted as a lodgepole well, and they didn't land in the basal lodgepole, but they went in the middle lodgepole. In the middle lodgepole, I came across some articles that showed that there's actually a handful of vertical wells that produced out of it, ranging from 42 barrels of oil of cumulative production to 44,000, or no, 2,400. So not a lot, but some oil from the middle lodgepole. With the Tai Wow, it was only a 4,400-foot lateral, and I think it was drilled back in like 2013, 2014, where most Bakken wells at that time were 2-mile laterals. Now they're going to 3 to 4 mile laterals. The Tai Wow came on at about a little over 100 barrels of oil a day with a 50% water cut, and it produced about 44,000 barrels of oil before being plugged and abandoned. And the middle lodgepole, the porosities were mostly around 2% or less, with some that got up to 6 to 7% porosity. With this test well, though, it's a large stratigraphic trap, is what I was told. And the Bakken, supposedly, it looks like it's Bakken oil that's moved up and charged the middle lodgepole. I've also been told by the prospect geologist that put this together for Hess that it's billions of barrels of oil in place, however big it is. And what I think about this lateral is it only produced 44,000 barrels of oil, where most Bakken wells, the good ones, you're looking at 400,000 barrel wells. So this is like a tenth of what you need, but it's only 4,400 feet. So I thought, what if this was a 2-mile lateral? Your production would go up quite a bit. What if it was a 4-mile lateral? So this is a pay zone in the Bakken fairway that might work in some areas to give additional inventory. And also this frac job now is like 12 years old. I understand like frac completions are a lot better today. So this is something where only one well, it didn't make money at that time, but I think it has future potential. And that's why I wrote a newsletter article about it somewhere back, I think 2019. Another play that I think we talked about, I might have given a presentation on this at one point, was this play in the Midale Rival up in Burke County in the Madison group. And in this play, you have about a 30 to 40 foot thick section with some porous limestones and dolomites, capped by anhydrite and underlined by anhydrite. And with this well, they drill into the upper rival, which is a lime grainstone, and then they frack up into the overlying Midale. The best well of this play is the Bush 32-1H. It came on at about 500 barrels of oil a day, and it's cumulatively produced over 224,000 barrels of oil and counting. Again, if you compare this to a Bakken well, it's about half of a good Bakken well for cumulative production. But this lateral, again, it's only 1 mile long, and the depth is only 6,000 feet. So it's half the lateral of a typical Bakken well, half the depth, and then the frac job was not as big of a typical Bakken well. I was told that this play was commercial to develop at about $50 oil. And there was a rig intermittently drilling development wells in this play in northern Burke County by Petra Harvester, which was part of Rockall, until COVID. And since COVID, there hasn't been a new well in this play, but it has semi-regular drilling for probably a few years in the late 2010s. And this map right here is showing color coding of the different wells that were both drilled or recompleted with multi-stage fracking in this play. And there's about, it was like 40 wells overall. The better wells were off towards kind of the northwest, crummier wells as you kind of move east, southeast. The dark gray area is where I use about 4 data sets to map out where there seem to be elevated hydrocarbon saturations. So again, this isn't a play that's going to be billions of barrels of oil, but I thought this ballpark could be maybe 100 million barrels of recoverable reserves. And so I'm kind of waiting for this play to get picked up by another operator with additional drilling. The company that holds it right now just produces the wells. I think it's Formentera, that's how you say it. And they're drilling Bakken wells, but they haven't come back to drill Madison wells yet. Some of these wells were 1 mile, some were 2 mile. The 2 mile wells didn't really seem a lot better than the 1 mile. So this is another play where you have production. Some of the wells have made money, some have probably lost money, but it needs to be a little bit better for somebody to probably re-enter it. So some potential. Last thing I'll talk about before I wrap up is the Spearfish Formation. And this is our shallowest oil producing unit in formation in the Williston Basin of North Dakota. Kind of on the top right here, I have a stratigraphic cross section where you have the spearfish is underlined by a regional unconformity. And there's this angular unconformity where various different formations subcrop underneath the spearfish. And the spearfish is oil charged and oil productive where it's underlined by portions of the Madison group where you have these carrier beds that have moved oil out. So the oil in the spearfish came from the Madison. And on the bottom right is some core photograph, like showing some oil fluorescence. In that middle map, it's showing production north of the border in Manitoba. And so I think the spearfish has been multiple times more productive north of the border in Manitoba and somewhat productive in North Dakota. So more production in Manitoba in like Wiskata and Pearson fields. In the spearfish, Travis Stoldorf, he wrote a newsletter article on this that I took his figures from. The spearfish has kind of gone through a progression of different play types. That early wells in the spearfish in like the top left, you had vertical wells primarily in the Newberg field where they had commingled production between this basal spearfish sand and upper Madison group reservoirs. Then in the 90s, there were these open hole horizontals that were drilled in this basal sand in the Newberg field. Drilled a lot by, I think it was Amerada Hess, which is now Hess Corporation. And some of those wells are still producing today. And then in the early 2010s, EOG came in, and maybe even late 2000s, and EOG first drilled about half a dozen short laterals that were fracked within this basal spearfish. The thing that changes is that this basal sand pinches out as you move to the east. And so the sands that EOG targeted, later Corinthian and Legacy, were slightly shallower sands in the spearfish, where you have up to 20% porosity, which is good, but the permeability values are low. So it's kind of like a tight sand. Oil's migrated in, but vertical wells can't really get commercial flow, but fracked wells do a little bit better. And this play at one point had 3 rigs drilling in it in 2014. Legacy was a company, Corinthian, and then Surge, they drilled a pad 2. And with these wells, it's only 3,000 feet deep. A lot of these laterals are only 2,000 to 3,000 feet long. And so they were drilling about 3 wells a month to 4 wells. And this was back when it took about 1 month to drill a Bakken well. So they were fast and cheap. And the average EUR that they were targeting was about a 75,000 barrel cumulative oil production, which is maybe about 20% of a Bakken well. And so it was a shallow, cheap unit to drill. But then oil prices dropped in late 2014 through 2016. And again, this play went into hiatus since then. A lot of these wells are still producing, but there hasn't been new drilling in this play now for, about 10 years. Looking at some of these wells that were drilled, This is a monthly production plot showing oil in green, blue is the water, and red is gas production. And on the left, you have a well that was only 2,200 feet long, and it has about a 50% water cut. It initially produced about 150 barrels of oil a day, and it's produced a little over 80,000 barrels, which is pretty good because the company was targeting wells that would eventually produce 75,000. On the right is another well. It also came on at about 150 barrels of oil a day. It's produced about 100,000 barrels of oil with a lot of water. And the two things I'd focus on is one is you have wells that produced 80 and 100,000 barrels of oil, and the laterals are only like 2,000 feet long. And now in the Bakken play, they're drilling 3-mile laterals, 4-mile laterals. So what if you went back in the spearfish and instead of drilling a 2,000 foot lateral, you drilled a 5,000 foot 1-mile lateral or a 2-mile lateral? Instead of getting 80 or 100,000 barrels, you'd be looking at getting 300,000 barrel wells, 400,000 barrel wells. This would be economic. The other thing I'd point out is Corinthian, they gave a talk at a conference once where they talked about basement-rooted fracture systems that caused water to come up. And they were trying to use 3D seismic to avoid the naturally fractured high water cut area. So the well on the right, high water cut, probably because it had a natural fracture system bringing water up. Well, on the left, probably low fracture system, less water. So there's things that can be learned from previous operators and previous notes that they learned. And so with that, I kind of wrap up today. We've talked about 5 different oil plays with different play extent areas. Interestingly, the ones that had some development, you know, the Red River, the Midale rival play and Spearfish, they're on the edge of the Bakken play to beyond it. And then the other wells that have other plays with just one test well were in the Bakken fairway. And that's one thing I point out is there's a lot of oil plays that the Bakken has overshadowed and probably swamped out, you know, for better or worse. And so it's not that we're running out of new targets to drill and develop. It's simply we haven't had a lot of exploration in North Dakota since the Bakken Three Forks came in and swamped things out. And so with that, I thank you guys for your time and be happy to answer any questions both online or in person here. So, all right.
Tim, where do you think industry's at? These non-Bakken, their interest compared to last 50 years or so?
Yeah, I think I've talked to you about this or mentioned it is I'd say in like the last 6 to 12 months, the amount of inquiries we're getting from companies looking at non-Bakken targets has been the highest since, you know, the price drop in 2014 to 16. So I'd say industry interest in looking at non-Bakken targets seems to be the highest in terms of inquiries we're getting at the survey and the core library for probably the last decade. And it's not driven by prices, because prices right now in the oil industry, they're not terrible, but they're not great. But what is happening is a lot of oil companies out there right now is they're in the unconventional world where their wells decline production really fast. If they don't keep drilling, their production drops. And when their production drops, it looks bad to their investors, whether they're public or private. And so there's a lot of oil companies that are running out of inventory where they don't have enough acreage in the Permian, the Eagle Ford, or the Bakken, you know, the Powder River to keep drilling and keep their production up. So they have to find new inventory. And so they're poking around at exploration. That hasn't translated into a bunch of exploration drilling yet, but the interest seems to be there.
Think about the level of M&A activity in the Permian. I think it's really hard for a smaller company to make any inroads. They're priced out already, so it makes sense to come up here and go prospecting.
Yes.
Question one, looks like from the 5 plays you mentioned, the BFA group, Red River, have like a geological content resource. While the logical idle rival spearfish more like some frac job potential upside, right? Say, you know, you got private equity, a couple of millions with the oil price range between $15 to $16. From that 5 play, which play are you going to pursue with the highest return of investment? The second one, if we go back to the Shadow Cat well,
Yeah.
which interval instead that you're talking.
Yeah, maybe start on the first one. I'd go back on like the Shadowcat test well. So the one question was if I was to place the Shadowcat test well, where would I place the lateral? The thing with the Shadowcat well is it looks like the Black Island is charged with gas. Are you going to drill an unconventional gas well in the Williston Basin and make money? I don't know. We have enough problems with, dealing with our Bakken gas. And so with that, the icebox formation in this area looks like it's in the oil window. And so that's where, like, are you going to go after oil or gas? Would you care? That's where, like, in the Shadowcat test well, it looks like the Black Island, like the log signature is there, that there's a bunch of gas in the Black Island. So if you're comfortable about going for gas, you go at the Black Island. If you were hoping to get oil, I do think like placing something in the lower ice box would be interesting. And there's this sand horizon that shows up in the ice box formation called the Crosby sand, and it looks like it's hydrocarbon saturated. Question though is it filled with oil or gas or both? So that's where really with the Shadowcat test, well, I think they hit an inflection point where they shallowed into the lower Red River, and I wonder if they would have deepened and gone the other way if they would have had a little bit better success. But with every unconventional play, it takes a few wells. When EOG hit in the partial field, they weren't the first ones to drill a Bakken well in North Dakota. I think there was like at least 15 to 20 horizontal Bakken wells before EOG hit on the partial 136, 236H. So your other question, like what play would I go after with private equity money? That's a fun one. I would like to say working for the state, we play with monopoly money, pitching ideas and putting, models together. But like right now, the Red River play, that, that's the one that actually has had recent drilling activity with Wolverine gas and oil. They're not they drilled 2 wells that are off confidential that are okay, and they have 2 wells on confidential. And I don't know the future of that. And, that'll be telling. If they keep drilling wells, that means they're probably making money. If they stop drilling wells forever, probably means they're not making money. So the Red River well one is interesting because with that porosity pod play, some of the porosity pods that are drilled, the porosity is there, the source rocks are there, but the oil isn't. So you drill some dry holes, and that has to factor in. I wonder, though, out of everything, the spearfish play. There were, I don't know if it was like 100 horizontal wells drilled up along the border, and some of them have been pretty good. And we also have quite a bit of log control and some core control, but that's one where, if I had private equity money and I was trying to actually make money on an oil play, that's the one where I think you could do a better job of drilling and engineering and completion now versus 10, 12 years ago. So, good questions.
Just to branch off of that, Russell asked for the Black Island icebox gas if there's indication that it was sour gas.
I don't think so. From what I remember, it's been 12 years, 13 years since I was looking at gas analyses, but I don't remember there being any H2S gas. I think the distinction there is shale-rich units that have clay, you get a sink for the H2S. So if there is or was H2S, there's something to kind of sink it and take it away. Versus like a carbonate unit with low clay, that H2S gas just hangs out. So I think with the Black Island icebox, I don't think H2S is an issue, to my knowledge, but I'm not an expert. Good question, though.
I think you're missing.
That sounds about right.
I would chalk myself up as a newer expert on that.
Near expert? Okay.
Online questions?
That was just Russell.
Talking about the spearfish and drilling longer laterals. I don't know the answer to this. What is the maximum physical depth you can shallow? I gotta hit up the drill.
Yeah, you probably know more about that than me, Mark. I mean, I heard back, 10 years ago, like with Bakken wells, for every, foot you went down, you could go out laterally. So if you went down 2 miles, you could go out 2 miles. With the spearfish wells back then, they went down 3,000 feet. They could go out 3,000 feet. But now, they're drilling 3 mile laterals. Is that about 30 to 40% of Bakken wells, Three Forks wells are now 3 mile laterals?
Yes.
So that's where maybe with the spearfish, maybe if it's 3,000 feet down, you do the math, maybe you could drill 4,500 foot laterals, but I'm not an engineer. So,
I don't know. People that.
yeah,
And when they get,
yeah.
some of these plays, obviously, Bakken is leased up, does that tie everything else up, so another smaller guy?
Yeah. Well, I recently talked to an unnamed company where they were saying that they don't hold the lease on their lease position in the core acreage. They don't own everything above it. And then I try to ask them, well, where is that? And they're like, well, we'd have to talk to our landmen people. But yeah, I think with some of these plays with the spearfish is something like that, especially outside the Bakken, you're not competing with the Bakken versus like that middle lodgepole test well. Like, yeah, that might work, but it's in the core of the Bakken, so yeah.
Is that a function? I wonder how the leases are set up in the first place.
Yeah, well, I've heard like in places like Louisiana, it's been very common going back many generations to just lease portions of the subsurface stratigraphy. And so wells in Louisiana have been drilled where they drill through good oil shows, but they haven't leased it. North Dakota Williston Basin, it traditionally, I think, and Jeff Markey comments, usually is everything, but over time, I think that's starting to change where some leases are more Bakken focused. Some are not. But
Louisiana, bad example, because that whole land situation down there is just totally screwed up.
okay.
No, because actually, cannot buy the minerals and hold forever. I think after a certain period of time, they always go back to the surface owner.
Huh.
And then after you find a discovery, you actually have to unitize the thing right away. So, yeah, it's Louisiana, they've got the French law been applied to it, and it's just, it's a nightmare. Here, I'm not a landman, but all landmen I know in Louisiana, they get paid double.
But I will say, I've drilled both in Louisiana and West Texas, for Louisiana over West Texas.
Well, yeah, well, West Texas got a lot of competition down there.
Yeah. The biggest hassle was you had to have 51% landowners or mineral owners to agree. For Louisiana, you could do a fourth unitization, but what often happened is you had dueling families who owned half, who no matter what, they would not talk to their cousin over there because he's the first ever. You're surprised how hard it is to get relatives to agree to something.
Yeah. Well, I can say there's a few companies that are poking around out here and maybe more than poking around, but they've commented that when they look at trying to make money in the Permian at this point, it's just too competitive. And that's where they're trying to look into places where there's less competition to get in. And it is interesting, like you see a lot of like the second-ish, third-tier-ish acreage of the Bakken. There's a lot of new operators that are showing up, drilling a few wells here and there, so, and they're not big companies that you've ever heard of. So I assume they're like private equity companies. So.
Perusing the State Water Commission GIS website and looking at the oil wells, and the red dots are the uncompleted locations, undeveloped locations. And so just can you give me a overview of the demand for fracking kind of in the Williston Basin? Where do you see it in the next 10 years?
I don't know if that's my comment to know, like the demand for fracking.
Well, no, where do you suspect the fracking, the most will be done and kind of relational?
I mean, it seems like the Bakken is in a phase where, I mean, for the next few years, we're still going to be very Bakken focused. Like there hasn't been a new discovery in something else that's really taken off in North Dakota. And even if something was drilled tomorrow, it would still take a while for something else that worked really well, that would take a while to emerge. And so like, it is seeming like with the Bakken that the levels it's at the current prices, I don't know. It seems like with Bakken and where we're at is probably where we're kind of going. I would say though, in the 10-year landscape, I would put money that there's going to be something else that comes up that's non-Bakken, non-Three Forks that takes off within the next 10 years, you know, and probably unconventional, something that requires fracking.
Well, I guess my understanding, my misunderstanding is it looks like everything's developed. Is there still a demand for fracking in the Bakken?
Oh yeah,
everywhere?
not everything in the Bakken has been developed. For one thing, even in the core acreage where companies say, oh yeah, we've developed 99% of our acreage. Well, some companies have abandoned the Three Forks, and I'll not name them. They have core Three Forks acreage where the surrounding spacing units, the Three Forks wells, are producing on par with Bakken, but unnamed operator isn't developing the Three Forks because they're bad at it. And they can't consistently make money. So there's acreage in the core of the Bakken Three Forks where the upper Three Forks and middle Three Forks probably has at least several hundred wells, a few thousand wells left. And then when you get to the kind of the second tier acreage of the Bakken, if you peruse through like the oil and gas division website, you'll see a lot of spacing units with one lateral still producing whole thing lease, and it hasn't been fully developed. And that's where there's smaller operators like one I was looking at, Rockport Energy, I think. They're drilling 3-mile laterals. I think it's in like southernish, southeastern McKinsey County. And they're drilling where the 2-mile laterals, 14 years ago didn't make money. But now they're drilling 3-mile laterals with bigger, better fracs, and they probably are making money. Dakota Resources, they're up in like northwestern North Dakota along the Montana border. They're drilling 3-mile laterals that, they're getting over 200,000 barrels of oil in the first year or something. They're making money. So this second tier Bakken acreage that 10, 12 years ago didn't make money, now it does at current prices with just longer laterals, bigger, better fracs. And it produces a lot more water. One thing I would say in the North Dakota, like every oil company seems to be very interested in studying and understanding the Indian Kara formation, Indian Kara for saltwater disposal. And that's where we had a recent visitor at the core library. They were looking at their Bakken cores and Bakken acreage, and they were pulling Indian Kara cores to understand saltwater disposal better. So there's still a lot of demand for fracking in the Bakken, but it's in the less productive areas where, so I still see a lot. There's still many thousands of Bakken Three Forks wells to be drilled. It's just we aren't the best, most productive acreage has largely been developed. That gives a somewhat of an answer or color, something to your question.
Well, then also your middle Three Forks article or study anyway showed kind of the southeast boundary was Sanish Peninsula.
Oh, where's Sanish? I'd have to go back and find that.
Below Newtown, below Newtown.
Yeah, I mean, we had the middle Three Forks is one where we have a rough outline of where that seems to work the best. But in that outlined area, there's parts that probably won't work well. There's another level of geology to do on the middle Three Forks. Its reservoir quality varies more than the upper Three Forks and middle Bakken. And I think that's one reason companies not all companies have continued to develop the middle Three Forks is some companies just simply don't know how to do good geology. And so they drill laterals into rocks filled with water, and then they produce mostly water. They don't even look at their core analyses. And then there's other companies that are I should stop speaking, so I'm not naming anybody, but there's some companies that look at the data and they drill into oily middle Three Forks and they produce oil. So I think in some ways with the Bakken Three Forks, I would say is a lot of good geology was done 10, 12, 14, 15 years ago. And a lot of good geology has been forgotten by companies that have gotten sometimes too engineering driven. But I don't know. The middle Three Forks, I could pull up a map if you wanted to talk about that at some point, maybe after the Q&A. But yeah, middle Three Forks is more risky than the other units.
Quick one, the Canadians, when you were there in April and May.
Yeah.
You mentioned that they're doing a lot of different types of laterals. They've been continuing to do that. Yeah,
so on the Canadian side of the Williston Basin, when I was up there earlier this year, it was interesting because in there, they both still have Bakken drilling going on. They also have most of their production and drilling is in the Madison. It's kind of shifted back to where the Madison is their primary unit in the Williston Basin. But both in the Madison and the Bakken, they've shifted away where there's very little fracking of horizontal wells in Saskatchewan's Williston Basin. Instead of fracking their laterals, they're just drilling multilaterals in different patterns. Because fracking got too expensive north of the border. And what I was told is typically when you drill more laterals and you don't frack them, your overall oil production and cumulative oil recovery goes down a little bit, but then your completion costs are a lot less and you produce less water, which reduces your operational costs. And up there, they had all kinds of crazy well patterns. My favorite one was the waffle. And they would drill a series of wells in one direction, and then they would drill a series of intersecting wells at 90 degrees. I think they were doing that, though, in the equivalent of the tar sand oil play. So it wasn't like Bakken wells. But up there, too, they had all kinds of things that the Stingray, I think, was one of the cool ones where they would drill a lateral perpendicular kitty corner across a section, and then they would do branches off of it that kind of looked like a stingray. So it's up there, less fracking, more laterals, touching more rock instead of fracking it with their boreholes.
And then they're turning around and coming back, which I think.
Yeah.
That's been done here.